Hello and welcome to R&D Mathematics. Today we are going to talk about midpoint of a line segment. Now again, let me put 2 points in our first quadrant. Again, it doesn't have to necessarily be in first quadrant, but just because it's easy to do and show you the proof, I'm putting these two in first quadrant. So let's take this line segment. By the way, a line is something going to both infinities, going in two directions. So a line. A ray, when you start at one point and go into infinity in one direction. A line segment, when you start at one point and when you end at one point. So this is a line segment. So those are the basic definitions. I'm recalling them. So a line does not have any endpoint. A ray has one endpoint. A line segment has two endpoints. Okay, now let's call this point C is our midpoint xy. Now the formula for C, the midpoint formula, the famous midpoint formula is very simple. X1 plus x2 divided by 2, y1 plus y2 divided by 2. Now again, I don't like just to memorize the formulas, but I would like to show you how these things are coming. So let's take this color blue and draw this line parallel to x-axis. And let's take color green and draw this line parallel to y-axis and this parallel to y-axis. And let's extend those. This extension will really help us to understand these lengths. Now, in this construction, I see two triangles. So let me give names A, B, C, D, and E. Triangle AEC and triangle ADB are similar. Now, can you guys remember what similar means? Similar means they are of the same shape, not necessarily the same size. Obviously, these two triangles are of two different sizes. ADB is much larger than AEC. But look at the shape. This angle. Shape means, when we say the shape is the same, all the angles must be the same. This angle is common, so it's the same. This is 90 degrees, so this is 90 degrees. They are the same. And this angle, because these two lines are parallel to y-axis, they are parallel with themselves. Because of that, these two are corresponding angles and they are the same. So now you can clearly see they are similar triangles. Now we have this result in geometry. In similar triangles, the ratio between two sides are going to be the same. So AE, let's take AD divide by AE. So the line parallel to x-axis, lines parallel to x-axis, this one and this one right here, going to be the same ratio. You have to take the same. So I'm in my numerator, I'm taking the big triangle. So AD, so BD, the corresponding one here is CE, and lastly the hypotenuse AB and AC. Right, now it's a matter of writing down this in, let me write it over here. AD, so this length, can you tell me what that length is? If you watched my last video, see, that length equals to this length minus this small length, right? So that length is x2 minus x1, that is AD. And AE, x minus x1, right? Because from here to here it's x, from here to here it's x, from here to here it's x1, right? And similarly, BD is going to be y2 minus y1 divided by CE is going to be y minus y1, right? Now AB minus AC, sorry, AB over AC. What is AB? Well, you may be thinking using our distance formula, AB is square root of, well, you don't have to go that far. Yes, if I going to write down just AB, that's going to be square root of x2 minus x1 squared plus y2 minus y1 squared. But look at this whole thing, AB divide by AC. When you divide AB by AC, this guy is the midpoint, so that is 2. Right, that is exactly 2. Now what I'm going to do, catch this part separately, catch the part having x's separately. So x2 minus x1 over x minus x1 equals 2. When I simplify, I have x2 minus x1 equals 2 times x minus x1. So I have, when I simplify this, x2 equals 2x minus 2x1. So I distribute right hand side, and I'm going to take this guy to over to right hand side, this guy. So plus x1. So what I am having here, x2 equals 2x minus x1, and when I take x1 to this side, 2x equal x1 plus x2, and x equal x1 plus x2 over 2. See this? Similarly, when I take the other part, I will get this y equals y1 plus y2 over 2. That's how the formula is coming from. Now let's see some examples. Now what if I ask you to find the midpoint joining these 2 points, this and this? Is really simple, right? So midpoint, let's call it M, is going to be x1 plus x2. So this plus this, so 2 and negative 4, you get negative 2 over 2. 6 plus this, so 6 and negative 2, you get 4 over 2. So the coordinate is negative 1 comma 2. Simple as that. Now by its own right, this formula itself is really simple, but we can again combine these things. When we learn more theory parts, we can combine these formulas with other theory parts to create beautiful problems, and that's in a future video. Thank you.